Hello everyone. In this video, we are going to solve some word problems from Loyola Jesuit College. We are going to solve probably 6 of them, although we'll solve 30 in total. So the first problem, first of all, let me tell you, this college is a very prestigious school, and they had the problems they said some can be very challenging. Although there are some easy problems, but you see what I mean when we continue the video. So let's go to the first problem and see what they have to offer us. So here we are given a very nice diagram here consisting of rectangles arranged in parallel to each other, and we are asked what fraction of the diagram is not shaded, is unshaded. So when we hear this word fraction here, fraction means part of something. So fraction is a part. Fraction actually means a part of something. A part of something. So here you have a whole figure here, and you want part of it here. And the way we represent fraction is to write the part you want. Let me say the part I want. The part I want, and we divide by the whole of it. So let us say now you have, let's say, something like 50, and you say you want 17 from 50. So that is, you want 17 part of 50, which is that we write it as 17 over 50. Here the 17 is the part you want. So let's leave that and see what the problem asks us here now. It says that what fraction of the diagram is unshaded. Let's find the whole first. So we'll look for the whole. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the whole is going to be here. And let's find the part they want. Notice they say the unshaded part. The unshaded part. So we will not bother ourselves with this white part here. Let's focus on the dark shaded ones. So this is 1, 2, 3. No, what? This is 1, sorry. This is unshaded, sorry. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and 7. So 7 parts is unshaded. So the fraction that is not shaded is 7 over 12. So 7 over 12 of it is not shaded, and our answer is 7 over 12. That is the solution. So let's look at another problem and see what they have to offer us as well. So in this problem, we are told that the area of a rectangular floor, of course, when we have floor, we have to draw this nice simple shape here to represent the floor, and the area is 2400 square centimeters. So the area, this side, let me show it in green. So the area, this side, this shaded side here, sorry about that, this side here is 2400. This area, the entire covering here, is 2400. And they say if the length of the floor is 60 centimeters, so the length of this floor is 60. What is the width? The width is this side here. This side here is the width. So this is the width. This is what they are asking us for. And let us recall one thing we know about rectangles here. For any rectangles you have here, where this is the length and this is the width, we know that the area is length times the width. Length times the width. Yeah. Okay. So let the width be W. Let's write the width as W here. Okay. So because the area is equals to the length times the width, we put everything. What I said, what is the area? The area is equals to 2400 square centimeters squared. The length is, this is the area, the length is equals to 60. So let's put everything in our formula and see what we can get. Here we will now be having 2400 centimeters squared. Let's just put 2400 is equals to 60 times the width, which is W. Here we have to divide both sides by 60 and divide both sides by 60. So now what we have is 160 cancel out 60. We'll have W here. No, that is the law of inverted upside down. So we have W here. This is equals to 2400 all divided by 60. So 0 cancel out the 0. Now let's see, with a calculator we can surely do this. This is 24 times 10 all divided by 6. So that should, this 6 here is 1 and 6 here is 4. So 4 times 10, this is 40. We put centimeter even though there is none here. There is just centimeter squared and just centimeter here, so ones cancel out. So the width here now, the width is equal to 40 centimeters. So this is a rectangle here. The length here is 40 centimeters. Sorry, not the length. The width here is 40 and the length here is 60 centimeters, which is what they asked us. So our answer here is 40 centimeters. A very nice problem. Mostly we made use of the fact that the area is equal to the width times the length, and we just plugged in the details in the formula. Now let's see what the next problem has to offer us. So here we are told that the average age of a group of 24 boys. So we have 24 boys. Let's say this is the group consisting of the 24 boys, and these are the boys here. It's always nice to draw diagrams when you are solving problems. It makes things easy, although we'll not even make it equal to 24. So the average age of a group of 24 boys is exactly 14 years. So the average age of these boys, average age of the guys in these places here is actually 14 years. 14 years. And then another boy is 16 years and 1 month old. Let the boy be A. So Mr. A, his age is 16 years and 1 month old. That is his age. And the boy joins the group. So they want to introduce him to this group, or he has been introduced. And we have to find the new average age of the group. So as he has joined the group, whatever age he, unless he's 0 years old, which is not true. Unless he's 0 years old, the average age of this group has to change actually. Because even if he's 1 month old or even 3 weeks old, the average age of the group must change because we have added a new number. Now, but what really is average age? When you say average age, what is it? Now, average, when we find average of something, we take the sum of that thing, the sum, and we divide by the number of the items. So we take the sum of items, all divided by the number of items. Now let me show you what I mean. Suppose that in this box here we have 5 and we have 7 and we have 3. Now what is the average number in this box here? Well, simply just like our formula says, what we will do, I write it in black. What we will do is to take the sum of the items, which is 5 plus 7 plus 3. And how many items we have? We have 3 items. So this gives us, I'll first of all add this to 10. I'll get plus 5 and I'll get 15. All divided by 3. So of course this is 5. So the average number in this box we have here is equals to 5. That thing applies to group as well. So let's come back to this group here of these boys present here. And we're told that the average age is 14 years. This should tell us that if we add the ages of the boys, let me say sum, okay? If we take the sum of ages of the boys, okay, say sum of ages for the boys, and we divide by the number, which is 24, we should get 14 according to the definition of average. So the ages of the boys, divide the sum of the ages of the boys divided by the number they are, which is 24, should give us 14 years. Now that will give us that the sum of ages, because if you multiply both sides by 24 here and multiply both sides by 24 here, this 24 they strike out, and we find that the sum of ages of boys is equals to 14 times 24, which is, let's see, 14 times 24, this is 16, 4 times, this is 5, so this is 6, and this is 2, so this is 6, this is 11, and then this is 3. So wait, this is 4, no, this is 4 really, this is 16, carry 1, this is 4 plus 1, this is 5, this is 6 and this is 2. So this 6, 11, and then 1 here is 3. So 3, 1, 3, we got. Okay, oh, we have, this is 8 here. Sorry about that. So this, we have 8 here. Okay, so this is 8 here. No, now 5 plus 8 is that is 5 plus 8, that is 13. So there is 3 here. Of course, we carried 1, so 336. So this is equals to 336. So the sum of the ages of the boys is 336. I had messed up on this addition here, on this multiplication here, but mistakes are made. So what do we do next now? After finding the sum of the ages of the boys here now, we have to archive this number. Let's just put it in the box, archive number, and see, and go back to our problem again. Now we are told that the average age is 14 years. But the next one I told you that another boy has joined them. Now let us find the new average age with this boy. To do that, we have to come back here and see. Since the guy is 16 years old plus 1 month, 16 years plus 1 month, but we don't want to work in months, so we convert this 1 month to years. To do this, 12 months is equals to a year. So 12 months is equals to 1 year. Divide both side by 12 and divide both side by 12. So cancel out 12. 1 month is equals to 1 over 12 years. So 1 month is 1 over 12 years. Now because of 16 years and 12 and 1 month, you cannot add this and get 17 years. No, you have to add the years, and to do that you have to convert the months to years. That is why we did the conversion process here. So what we will do here now is to see that the boy's age is 16 plus 1 over 12 years old. That is his age. Or maybe we may write 16 number 1 over 12. That is age of the boy. But we'll not put in decimal first, since there is really no need to. So now the age of the boys now, ages of the boys will then be ages of the boy, ages of the boys, or let's even call it sum of ages, so that it will be in line with what we have here now. Now the sum of ages now, will then be sum of ages would then be 336 plus the boy's age, because we have to add the boy's age since the boy has been welcomed into the group. So this is plus 16 plus 1 all divided by 12. Yeah, this is the sum of the ages. We will not bother simplifying it, and their number now will be 24 plus 1. Since the boy is we count the boy as 1, we cannot count the boy as 2 since he's only 1 boy. So the number is now 24 plus 1. So the new average, our new average will be the sum of the ages of the boys, which is now 336 plus 16 plus 1 over 12 all divided by 24 plus 1. So this is equals to now 336 plus 16 plus 1 over 12 is giving us 352. This is equal to 352.08. okay, divided by 25. So 352.08 divided by 25. That is our new, the sum of the ages. Now if you divide this number by 25, what we'll get here is 14.08, or we may write approximately 14.1. So 14.1 is the new average age of students in the class. Now I will recap on what I said. Now this is the problem you presented to us. We are told that a group of 24 boys has 14 years as average age, and that boy was invited to join them. The boy is 16 years and 1 month old. He joined them. So the average age will change. Now what we did here is I'll stop here now, is to see that the boys' age, the age of boys, we presented the age of the boys, ages of boys, all over their number is equals to 14, And when we got the ages of the boys in total as a sum, we kept the number apart. We got 336. And the next thing we did was to find the age of that boy. But with this month, we got rid of this 1 month by converting it to years. It's 1/12 a year. So when we add the total ages and divided by 25, because they're not 25 in number, we got 14.08 as our answer. So you can go through it if you are feeling a little bit comfortable in the explanation. But I think this one is enough for us now. Now let's see what the next problem has for us. Okay, here we are told to simplify this expression. Now whenever we have to simplify fractions that have this 2 number 3/4, let's write the question first down. So we have to simplify 2 number 3/4 and then divided by 2/3, and then we have to multiply by 1 number 5/6. No, that is not, that is a 7. So 5/7, and then we have to subtract 1/4. So here now we have to convert this. So whenever I work with fraction like this, always convert it to simple fraction. Do 4 times 2 is 8. 8 plus 3 is 11. So we have 11 divided by 4. I'm multiplying by, sorry, let me put this is a division. Okay, 11/4. We are dividing 2/3. Then we're multiplying by this 7 times 1, 7 plus 5. This is 12/7. Subtracting 5/4, of course. Now the key step here is to change your division to multiplication, but you don't just do it. Like if you have 2/3 and you have to divide by, let's say, 7/5, you can write it as 2/3 times 5/7. So this is how we change division to multiplication, by inverting this, turn it upside down. So let's use this principle here and change all the division to multiplication so that we can multiply directly and we'll be happy. So this is 11 all divided by 4. Now this is times. Now this will be 3 all divided by 2. This is times 12/7, and this is minus 5/4. So what we'll do here now is to, although I would like to cancel 2 and 12, but I'll work with 4 since it's better. So 4 here is 1, and then 4 here is 3, because 4 will just do the job at once. If we cancel 2, let's try to cancel 2. If we say, let's say, if we say this is 4 here, so if we say 2 here 1 and 2 here 6, we still have 6 here to worry about. Okay, so that's why I started with 4. Let's just do everything here. 11/4 times 3/2 times 12/7 minus 5/4. So like I said, we'll cancel out the 4 first. 4 here 1 and 4 here 3. There's nothing to cancel again. 2, 7, they don't divide anything above. So here we'll not even bother canceling because a minus sign, not a plus sign. So when we multiply 2 and 7, we're getting 14 here. And then when we multiply 11 times 3, we get 33. Multiply by 3, we get 99. So this is 99 divided by 11 minus 5/4. Here, the LCM here is between 7 and 4. Since 2 is already in 4. So 7 times 4 is 28. So 28 here. So 14 divided by 28. Of course, that is 2. 14 divided by 28 is 2. So 99 times 2, that is 198. Since we just do 100 times 2 and get 200, and then take out 2, so we get 198. So like we do 100 times 2, we get 200, and then we subtract 2, because 99 and 99, they are just short of 100 by 2. So this will give us 198 minus, now this will be 7 times 5, so this will be 35. So let me wipe this down part and let's see what we have here. No, so let's put it in black. So what we have would be 198 minus 35. So let's 198 minus 35. So this is 3, this is 6, and this is 1. So this is 163 all divided by 28. uh, did, don't think nothing really cancels out, since this there's no division. The one is odd, this one is even. Can't really see. So 163 divided by 28, that's what we got. And for this fraction here, so we get 163 all divided by 28. If something cancels out, you can just do it. I did not practice for the video beforehand, so let's be satisfied with this and go to the next problem. Okay, here we asked to express these fractions in order of ascending, like in ascending order. So we have 2 over 3, 1 over 2, 4 over 5, and then 3 over 4. Now, this is actually one of my favorite problem in the list of problems I have here. Reason because I always like solving problems like this. Now, what they ask us to do is that to find out which one is greater between this A, quantity B, quantity C, and quantity D. So we call them A, B, C, and D. And if we know which one is greater, let's say B is more than C, we will arrange it in a way that B comes first before C, if B is more than C. Now, they're not easy to arrange. One of the first method, I don't know how we'll do two methods, but let's see. All the first method is we'll actually find the LCM. So LCM method, let's do the two method. Let's not be lazy. Okay. So let's find the LCM. Let's find the LCM. So LCM method. Let's find the LCM method now. So we have 3, 2, 5. Is this a 4? Yeah, it's a 4. I wipe this out. 3, 2, 5, and then 4. What is the LCM of these numbers here? Well, we need to look for the LCM of 3, 2, and 5. Since 3, 4, and 5. Since 2 is already in 4. This is 12 times 5. This should be 60. So this is 60. So this is 60. After getting the LCM, we will now express all of them in the same denominator. And I'll tell you why we do that after we have done it only. So I'll write it neatly like this, that the LCM is equals to 60. So let's see 2 over 3. We want to convert this 3 to 60. We have to multiply both numerator and denominator by, let's say, 20, because 20 times 3 is 60. So this will give us 40 over 60 when it is done. So this 3 over 2, this is A. Let's call it the A. So this let's call this side A, B, C, and D. So A is 40 over 60. What about B? For B parts, let's say for B, we'll have 1 over 2. Now we're going to multiply this by 30 and divide by 30. This will give us 30 over 60, and this is B. Let's see. What about C parts here? So we have, let's do the different color. For C parts here, we have 4 over 5. And how do we get from here to 60? Of course, I think we have to multiply by 12. Yeah, 12. Now 40 times 12. Oh wait, my pen. Okay, 4. So this is 12. So what? 5 times 12 is 60. Yes, and then 4 times 12. This should be 48. So it's 12, 4, 8, and 1. So yeah, 48. Now, what do we do next? This is equal. So this is C. C is 48 over 60. Let's look for D, the last number there. So D is 3 over 4. So 3 over 4 here, I have to multiply by, how do we get from 4 to 60? Let's see. Divide 60 by 4. So you get 2 here, you get, no, this is 1. So you get 4 here and 2, 0. So 5. So 15. So we have to actually multiply by 15. So I will have to multiply 4 by 15 to get 60. I know that most of you actually know that we multiply by 15, but really most of us uh don't really mm, multiply by head like that easily. We do it the way we know. So this is 15, and this is 15 as well. Let's say 3 times 15, that should be 45. I know that one by head. So, and this is 60. So this is D. So the A, B, C, and D. Our A, B, C, and D, which is 2 over 3, 2 over 3, 1 over 2, 4 over 5, and then 3 over 4. They all give us 40 over 60, 30 over 60, and 48 over 60, and then 45 over 60. Now, these fractions are the same thing. Now, the reason why we put them in the same denominator is because of one reason only. If you have two fractions in the same denominator, let's say 2 over 5 and then 3 over 5, the one with the bigger numerator here, which is 3, is greater than this one with the smaller numerator. So 3 over 5 is actually greater than 2 over 5, only because we know they are in the same denominator. If this was not the case, if it was 2 over 7 and 3 over 5, we will not be able to compare these two numbers at all, or because we cannot tell whether this is greater than this. Unless you have to maybe use your calculator and punch them and see what value they give you, and then you compare the value. But directly, you cannot really compare them easily, unless they're in the same denominator. So that is why when we have problems like this, we try to put them in the same denominator. So we try to put them in the same denominator. That's how we have to express all of them in terms of 60, which is their LCM there. So since they're in the same denominator, we can easily arrange them. We know that 48 is the biggest. So let me put that in different color. So 48 is the biggest. So we now have 48 over 60 first, and then the second to the biggest is 45 over 60. Then we now have 40 over 60, and then 30 over 60. Okay, so this thing, the 48 over 60 is the one of 4 over 5, 4 over 5, and then 45 over 60 is one of 3 over 4, and then 40 over 60 is the one of 2 over 3, and finally 30 over 60 is one of 1 over 2. So the fraction they ask us to arrange, this is the correct arrangement according to the biggest: 4 over 5, 3 over 4, 2 over 3, and 1 over 2. Now if we were asked to arrange it in terms of the smallest, of course this will be 1 over 2, 2 over 3, 3 over 4, and 4 over 5. I mentioned that I was going to use a different method to solve this, but I would not now, because I noticed that this problem actually problem like this are in the past questions I have to solve. They're up to 500 problems, and we will solve all of them. So in that, maybe when I'm solving a problem new time, I will use a different method, so I will not bore you to death. If I probably use the method now, use it again. So let's see what the next problem has for us. So here now, we are given, they told us, given that some particular equation, this whole thing equals this whole thing, we should find the value of x. So let's write it down. We have 2 over 3, which is multiplying 9 minus 6x. This is equals to 4 whole number x plus 3. So to solve this, what we'll do, I think this 2 over 3 is annoying. Even as a math student like me, this 2 over 3 is somehow annoying. So what I will do, I will try to remove it, and I will not remove it simply by erasing it. Say I just come here and just say, okay, I don't like this, let me erase 2 over 3. Yeah, no, it's because it will change the final answer, and I don't think that is a way to go in life. Even though things are difficult, it's not by, it can make things easy for us, but sometimes it's not really by removing 2 over 3. So what we'll do here is to just, the way to go, to remove 2 over 3 here, multiply both sides by 3 and multiply here by 3. This will cancel out the 3. At least this will be 2 times 9 minus 6x when it is being cancelled out. Now this one is more, this one is better. Removing it this way is more, like, it makes sense and logical. Having to clean it will be silly for us. So let's work with this. So of course this 3 here, we don't want to put it here. You can just multiply it by 4. This will be confusing for. Let's just put 3 times 4 is 12. So this is 12 times x plus 3. And of course you can simply do 2 times 9, 2 times 6, but we don't have to suffer like that. We can simply divide both sides by 2 as well. Divide both sides by 2 as well. When you see a way to make your life easy, you do it. So 2 here is 1 and 2 here is 6. So what that one will bring us to is that 9 minus 6x is equals to 6 times x plus 3. I think that is quite better for us. So let's go to let's do the line here and continue from here. So we stopped at 9 minus 6x equals to, now let's put a bracket here. Now 6 times x, this will give us 6x. 6 times 3, this will give us plus 18. Now what we'll do here is what they call collecting of like terms. I'll prefer to push this 6x over this side here, because if I do that, this minus will go. Mostly some people don't like minus, so I'll not, those people who don't like minus, I'll not inconvenience them for any reason. So what I'll do is to push this 6x over here and bring the 18 here, but we will still get the minus. So of course I'm sorry, I tried my best, but we could not. Sometimes in life you can try and still not succeed. So here we have 9 minus 18 plus, sorry, this is not plus, 6x equals to 6s plus 6s. Of course, when the 6s is crossing the sign, you have to give up this sign for having to cross. You cannot eat your cake and have it. So 9 minus 18 is negative 9, of course. So the negative I was running for is 9 here, but I think we don't have problem with it. The reason why it's negative 9 is because 9 is smaller than 18. Yeah, so and when you're taking, yeah, when I'm doing the subtraction, the sign of the number we're going to use will be the sign of 18. 9 cannot dominate 18. 9 is positive, but we cannot have positive 9 because 18, the biggest number, has to dominate the sign. This only works for subtraction, so don't think it's the general rule. When you are subtracting numbers and addition, if you're multiplying them, it depends on the sign of the two numbers involved. So this whole thing here equals negative 9 will be 12x, because 6 plus 6 is 12. And the next step is to divide both sides by, no, that is not a division, this is a triangle. So this is x. So divide both sides by, no, Microsoft whiteboard keeps, divide both sides by 12. Divide both sides by 12. So 12 cancel 12. Now 3 here is 3, and then 3 here is 4. So I'll bring x here. I'm not a left-hand person. I'll bring x here. This is negative 3 all divided by 4. So here, that is, we have gotten our answer. X is equals to negative 3 all over 4. So we have solved the 6 problems we promised, and this is the first part of the lecture. In the next part, we will work the remaining, we'll work our extra 6 problem as well. Thank you.